Hi everyone, and welcome back to my video series on coding with Flutter. Today we're going to talk about state management in Flutter, and to do that I'm going to show you a simple app that I've built to manage multiple counters. So the way this app works is that you can show a list of counters, you can add new counters, you can increment or decrement existing counters, and you can also delete counters. Now, to make things more interesting, all the counters are stored in Firebase Database, which means that we can keep multiple clients in sync. So if I open the iOS simulator and the Android emulator at the same time, you can see how the counters stay in sync as I change values. Okay, this is made possible by Firebase Realtime Database, which is something that you could use in your apps and that I will show you briefly today. Now, at the bottom, we have 4 tabs named setState, Streams, Scoped Model, and Redux. Each page shows exactly the same counters, but they are all implemented with different state management techniques. So the goal of this video is to show you how to use the most common state management techniques in Flutter. We'll see how they can be applied to this simple example, and hopefully you'll get a feel for which is the most appropriate for your specific app or use case. Before we start, I want to mention that the source code for this is on GitHub, so you are encouraged to check it out and try it by yourself. Okay, so we're now ready to get started. First, I want to give you an overview of the building blocks that we need for this example. So let's head over to our IDE and let's start with the database. So at the top of the file, we define a counter, which is our model, and it is a class that has an ID and a value, which are both of type integer. So very simple. Then we define our database, which has 3 methods: a create counter, which creates a new counter, a set counter, which sets the value of a specific counter, and also a delete counter method. We then have an implementation for this database interface, and this is where we hook up our Firebase database. So before I explain this code, let me show you a snapshot of the current database. So if we head over to our Firebase console on the database tab, we can see it here. So this is the structure of our database, and you can think of it as a simple JSON structure with keys and values. So at the root, we have a counters node, and then each counter is defined by a number. This number is a Unix timestamp that defines when the counter was created and makes it easy to sort the counters by creation date. We'll look at how this is generated in a second. Inside each counter, we then have just the value. And as you can see, we can update the counters in the app, and the values are changed immediately in the database and highlighted as well. Now, one thing that I want to point out is that the structure of this database is very simple, and this is on purpose. There is no concept of user in the app, and clients have complete read and write access to the database. And this is because I really just want to focus on state management here and keep things simple. Okay, so let's get back to our IDE. Now, if we want to get a reference to a child node in the database, we need to specify a path to it, and this is done here by saying root path / counter ID. And you notice that the root path is defined here, and it has the value counters, which matches the name that we have in our database over here. So once we have a database reference, we can use it to set a counter or to delete a counter. We also have a create counter method, and we can see how this works. So in here we get the current time and convert it to a Unix timestamp, which is an integer value. And then we can use this to create a counter instance with an initial value of 0. So the setCounter and delete counter methods are all we need to write our counters to the database. Now, in order to read the value of the counters, we need to define a stream. And the reason why we use a stream and not a future, for example, is that we want to be notified every time any counter is modified so that we can rebuild our UI. So our counter stream here method creates a node stream, and if we head over to this class over here, we can see that it's a generic class of type T. And in our case, we use it to get a stream of values of type list of counter. So what this class does is to take an API path and a parser, and then it finds the database reference to that API path, and then it gets an event stream that is generated when there's a change on the value of our database reference. Note that the API path of our database reference doesn't point to a specific counter, but to the overall counters node, because it's past the root path that is defined over here. So when we get the onValue stream, we are effectively getting a stream of event where event represents all the counters. What we actually want though is a stream of list of counter. So what we do here is to use the map method to transform our stream events to list of counter objects. And the mapping itself is done with a node parser, which is defined here, and in our case is defined and implemented by the counters parser class. So what this does is to take the values inside the event object that we receive from the stream and converts them into a list of counters sorted by creation time. So in more detail, we read the event snapshot.value, which is a dictionary of key value pairs. We then iterate through all the keys, which we read out as strings, and then we create our counter object by transforming the string keys back to integers and reading out the values, which are already integers. And finally, we just sort the counters and return them. Now, one more thing that I want to say is that all the logic for reading and parsing our counter stream is shared between the node stream and the node parser, which are both generic classes of type T. Now, the reason for this is that if we were to expand our database to store additional entities that can be read as streams, it would be as simple as implementing a new node parser and providing an API path. So node stream and node parser are highly reusable classes. So this is great. With just a create counter, set counter, delete counter, and counter stream methods, we have everything that we need in order to connect our app to Firebase Realtime Database and manage our counters. So we are now done talking about the database. Okay, so before I show you how each page works, I also want to take a look at some widgets that we will be using as building blocks for our UI. And the first one is called placeholder content. And this is a screen that is shown when there are no items in the list. So let me show you how this looks like. If I delete all the counters, we're gonna get this text right in the middle of the screen. Okay, so the next UI item that I want to show you is called the list items builder. And this is a class that does a few things for us. It builds the list of counters. It shows the placeholder content if there are no counters. And also it shows a circular progress indicator if we are still loading, for example, when we start the app the first time. So this is a common UI technique that can be used to show 3 different states for our UI. And these 3 states are loading, empty, and normal state. One thing to notice with this list items builder class is that it also works with a generic T parameter. In our code, we will use this with instances of type counter, But again, you could reuse this if you add more models to your app and you wanted to display them as a list. In any case, we have a buildList method over here, which in turn calls listView.builder. It gives it the correct items.length, and then calls the item builder, which was passed to list items builder over here. So we can see this class as a wrapper for listView.builder, which also takes care of the loading and empty states. So the last widget that I need to show you is a class called counter list tile, and let's just create one so we know what we're talking about. So this is what we use to render each counter, and this is a stateless widget that takes a counter object and on decrement, on increment, and on dismissed callbacks. Now, I'm not going to go through a lot of detail about this class because mainly it's just building UI, but the only thing I wanted to point out is that inside here we use this dismissible widget, which is what we use to delete our counters. So make sure to check the documentation for dismissible if you want to use this to implement a swipe to dismiss gesture like this. Okay, so we have seen how the database is built and what UI widgets we are going to use to render our pages. So we're now ready to see how the different pages are built, and we're gonna start with the first one, which is called setState. Now, setState is one of the first things that you encounter when you start Flutter programming. And typically, you would have a stateful widget subclass, such as this one, and you declare some state, like we have done here with our counters variable. In order to update the UI for your page, you need to call setState somewhere, and this causes a rebuild of our widget tree. Now, the way things work in this page is that we update state by listening to our stream over here, and when a new value is available, we call setState and update the counter's value. Now, we can subscribe to the stream in init state, and this guarantees that we are able to update every time a new value is available on the stream. Now, when we create a subscription such as this one, it is also important to cancel it when our widget is no longer needed, so that we stop receiving updates from the stream. And the place to do this is in the dispose method over here, where we cancel our subscription. Okay, so when the user takes any action on our counters, such as incrementing them or decrementing them, we update the value of the counter, and then we update it in the database. So in turn, we then receive a new stream value, and we call setState over here. Just note that there are no calls to setState directly after we modify the counters here. And this is because our new state really comes from Firebase via the stream that we have registered. Okay, so if we head over to our build method, we can see how our page is rendered. So over here, we have a scaffold with a navbar, which is at the top of the page. And then for the body, we call this build content method. This is where we use the list items builder that I've shown you before. So we define it as a list items builder of type counter. And for the items array, it takes the counter's value that we set when we call setState. We then specify an item builder, and inside the builder code, we return a counter list tile widget, which we also have seen before. We specify a key, which needs to be unique so that dismissible works properly. And then we give it the counter object, that is our model, and then we specify the callbacks that need to be called when the user interacts with the widget. So this is what triggers the updates to the database as we have seen over here. Okay, so this all works, but it's not a great implementation. For once, we had to explicitly keep track of our counters within the page. And we need some boilerplate code inside init state and this post to set up and cancel our subscription. Yeah, ideally, what we want is to have a page that is only responsible for rendering our UI and delegate any state management elsewhere. And the reason for this is that the state and the code to transform our model belong to the business logic layer of the app and really is not something that should be within our widget class. So let's take a look at the next page and see an alternative approach. Okay, so we are ready to introduce a new class in Flutter called StreamBuilder, which we use over here. Now, the Flutter documentation defines StreamBuilder as a widget that builds itself based on the latest snapshot of interaction with the specified stream, and whose build strategy is given by a builder. So, how does this work? So here we define a StreamBuilder of type list of counter, and provide a stream and a builder property. The stream is the one that is passed to our streams page at the top over here, and this is created from the database as we have seen before. The builder is a method that is called every time there is a new value on the stream, and we can get access to that value via the snapshot parameter. We then use the snapshot to extract our list of counters, and if there is no data, we just pass null. Everything else is handled by the list items builder that we had seen before. One thing to notice here is that the streams page does not need to keep track of any state at all, and that's because StreamBuilder does all the heavy lifting for us. So when we call any of the database methods to update our counters, a new value will be pushed to the stream and the stream builder is called again. This is great because streams page is now a stateless widget. There is no manual state management within it and no setup and no teardown. And stream builder takes care of rebuilding the UI when there is a new value. So for this example app, StreamBuilder works great because the data stored in Firebase Database can be directly parsed into a stream of list of counter objects, and these can be directly rendered by the UI. Okay, so we have looked at setState and StreamBuilder, which are two ways that you can use to manage state in your app. These are both offered as part of the Flutter SDK. Next, we are going to look at two different techniques for managing state, and I'm talking about Scoped Model and Redux, and these are available as third-party libraries. So let's head on to the first one, which is a Scoped Model. One thing that I want to mention just quickly is that if you want to use Scoped Model or Redux, you actually had to import them in your pubspec.yaml file, so make sure you do that if you need to use them. Okay, back to Scoped Model, and let's see how this works. The first thing that we need to do is to define a counters model. This needs to extend model, which is a class that is part of the Scoped Model library. The most important line in this class is here, where we call notify listeners. And we need to call this every time there is a change in our model. As we have already discovered in our example, the model is a list of counters, and this changes when there is a new value on the stream. So the way that we can make this work is by listening to changes on the stream, and when a new value is received, we can store it and notify the listeners. Then, in our build content method, we use a Scoped Model descendant object to get access to our counters model via a builder method. And then we have our list items builder as usual. Note how we read the counters out of the model, just like this over here. There is one thing that I haven't covered in this implementation, and that is how the Scoped Model page is created. So if we head to the bottom navigation file, it has a build body method, which is where we create all the various pages. Now for Scoped Model, we need to create a Scoped Model of counters model, and then give it a model and a child. Note how we pass our stream to counters model and the database to scoped model page. So there is a little bit more setup here than in our StreamBuilder example, and that's because we need to create a parent scoped model object for our scoped model page. And inside the page itself, we create a scoped model descendant here, which will call the builder every time the model updates. So for this specific case, it looks like using scoped model is a little bit more work than just using StreamBuilder. But what scoped model does though is to give you a way to lift your state out of your widget. And as long as you define a scoped model as an ancestor of your widget anywhere in your widget tree, then you can use a scoped model descendant to get access to the model. So if your specific use case doesn't use streams, but you need a good abstraction for state management, then scoped model can be a much more elegant solution than having stateful widgets and calling setState inside them. In other words, scoped model is a very good choice for decoupling your business logic from your UI logic. And I encourage you to take a look at the documentation for scoped model and see how you can use it to manage state in your apps. Okay, so the last state management technique that we're going to talk about is called Redux. And this is something that is quite popular, especially in the web development world, but it is also available to use in Flutter if you wish to do so. So we're going to take a look at how our counters example works with Redux, but before we do that, let me just briefly show you a diagram of how Redux works. And let me just say, this is going to be a very brief overview of Redux, and I encourage you to read more about it if you're interested. But in any case, we have a view, which is our widget in this case. And the way the view requests changes to the state is by dispatching an action. The action holds all the information that is necessary to update the state, and it is then processed by a middleware and by a reducer. Middleware is typically an optional step in Redux, but we are actually going to use it in our example as we need to talk to the database, which works with asynchronous methods. A reducer is a component that takes the old state, an action, and produces the new state, which is then saved into the store. And there is a way for widgets to subscribe to the store so that they can render themselves when the state updates. Okay, so let's get back to our code and see how everything fits together. So we have a Redux model which contains our list of counters. We then have some actions, a middleware class, a reducer, and then the Redux page itself. And I'll talk through each one of these in detail. But the first thing to notice is that our Redux page doesn't need a reference to the database or to the stream directly. And this is because these are completely decoupled from the page and they are handled elsewhere. We can also see in our build method that we get access to the store via this store builder object. And this is what we use to get our counters and render the UI. So there are some similarities between the Redux page and the previous examples, but we'll now see that the rest of the implementation is actually quite different. So first of all, we modify our counters by dispatching actions to the store, which is done over here. So the actions are defined here. And as we can see, they are just simple classes which hold an intent to modify the state in some way. Then we have a counters middleware, and really this is the class that talks to our database and the stream. So the middleware has a call method which we use to inspect the incoming actions and update the database accordingly. I have also added a listen method, which is where we get new values from the stream. So every time there is a new value, we dispatch an action called update counters action. Finally, we have a reducer, which is a pure function that updates our Redux model. So the reducer checks if the action is of type update counters action, and returns a new Redux model. After the reducer is called, we get a new model in the store builder and we can update the UI. In this specific case, our reducer also needs to check for an action of type delete counter action. And the reason for that is that our list items use the dismissible widget, and there is a requirement that every time we dismiss an item, we update the state immediately, so that the UI stays in sync with the state. So in our specific use case, we need to add this in the Redux implementation. Now, this code looks a little bit complicated, but we are not done yet. So if we head to our bottom navigation widget, we can see how everything is wired up. So we first create our counters middleware and give it the database and the stream. And then we create the Redux store and pass the reducer and an initial state. Once this is set up, we have to call middleware.listen so that we can observe new values in the stream. And finally, we create a store provider and pass our Redux page as its child. You can see that this last step is similar to the setup that we had for our scoped model example. But here we also need to set up the extra things that are needed because we have a store, a middleware, and a reducer. So while Redux completely decouples our page from any business logic or even the database and the stream that we need to talk to Firebase, for this case it seems to be quite a heavyweight solution. So here we have to do some extra work to fit our simple business logic around the Redux architecture. So I'm not going to talk more about Redux, but I will just say that it is a powerful abstraction that you can use to manage state in your apps, but you need to be aware that when it comes with a fair bit of boilerplate code, and you might not need all the flexibility that Redux offers. So think carefully about whether this is the right approach for you, or whether something simpler like scoped model would work better in your use case. Okay, so this has been a long overview of various state management techniques that you can use in Flutter. And if I had to pick a winner for this specific use case, I would definitely say that StreamBuilder takes the prize. And that's because it does exactly what we need with the least amount of code. And in fact, in this example, it uses less than 70 lines of code. A close second would be scoped model because it is very easy to set up, it deals gracefully with asynchronous code and lifts state and business logic out of your widgets. So going forward, as you build your own apps, I encourage you to ask yourself what is the best techniques for your use case, and keep in mind that StreamBuilder and scoped model are very powerful abstractions that work really well in Flutter. Okay, so that's it for today. I would like to invite you again to check out the GitHub repo for this video, and you can download the code here and see how it works. And finally, you can head to my website, codingwithflutter.com, and here you can sign up for updates as I publish new articles and videos. I hope you have enjoyed this video, and if you have any questions, make sure to ask me and I'll be happy to help. Thank you for watching, and I'll see you on the next videos.